Hey, Calc BC, welcome back. Good to see you guys again. Just wanted to give you some information right now, a video about how do we tell if we have a homogeneous function. Because the next section or the next part of our section deals with solving differential equations that are called homogeneous differential equations. Excuse me. And so before we can even get to that though, we better define what the heck it is we're talking about when we say homogeneous differential equations, or just homogeneous functions in general. So let me explain. Oh my goodness, look at that. That's from the last video we just saw. I just finished creating that video and now I want to get into the homogeneous differential equation. So here we go. When we talk about homogeneous functions, functions, okay, we mean a very specific kind of function, okay, and so let's see here. Let me give you a definition. This is going to be a function of two variables, okay, so a f is a homogeneous function. Oh, come on. Of x and y of degree n if, okay, f of t times x, t times y is equal to t to the n times f of x, y. All right, so that's what we mean by homogeneous function. It's a function of x and y, okay, that when we plug tx and ty into the same function, we can actually bring t to the n out and then get the original function back. So let me show you a quick example of what we're talking about here. So let's see here. My function, f of xy, is x squared y minus 4x cubed plus 3xy squared. Okay. And my directions might say, you know, is f of xy a homogeneous function? Or if it is, you know, if they're giving it away that it is only, what is the degree of the homogeneous function f of xy? Whatever. Okay. The idea is the same. What you do is you take your function and you put tx and ty into the same function. So here where we had x squared, I now have tx quantity squared. And where I had y, I have ty, okay, minus 4 times, now x cubed, so now it's tx quantity cubed, okay? And where it's 3 times x, tx, and y squared, ty quantity squared. And now look, when I square tx, that quantity squared, I get t squared x squared, right, times ty minus 4t cubed x cubed, right? And look, here I get 3tx times t squared y squared. And in these two terms on the end here, there's t's that are, you know, floating around there. That's t cubed times x squared y minus 4t cubed x cubed. Look, here's 3t cubed xy squared. What do you see in all three of those terms? You see a t cubed. Factor it out. And look what happens. X squared y. Let me put that in parentheses there. Minus 4x cubed, right? Plus 3xy squared. Look familiar? Yeah, that's f of xy. This is t cubed times f of xy. So if my question was, is my original function f of xy homogeneous? Yes, it is homogeneous. If my question is it homogeneous and what is the degree? There you go. It's a third degree homogeneous function. All right. Does that make sense? It's just a matter of plugging in tx and ty into your equation and seeing can you then factor out a common factor of t to some power. Okay. Let's try this one. F of xy is x e to the x over y plus y sine of y over x. Okay, is that a homogeneous differential equation? Let's find out. Let's put in tx and ty. So tx, ty. Well, look, I get tx e to the tx over ty plus ty sine of ty over tx. Now, it's interesting because in these fractions, like the e's power, right, the t's are just going to cancel out. Inside the sine function, the t's are just going to cancel out. And look, there's a common factor of t in both of these. So we get x e to the x over y plus y sine of y over x, which of course is f of xy. So the answer is yes, that pink function at the top there, or magenta or whatever color you want to call it, that is a homogeneous function of degree 1. All right, so far so good. Excellent. One last one, and that hopefully will be it for explaining homogeneous functions. Now, what I'm going to do is do one last one, and you may have already guessed, but we'll see let's see if you were right. F of xy is going to be x plus y squared. All right, and let's check and see, do we have a homogeneous differential equation? Or sorry, not differential, just a homogeneous function. Differential equations are for the next video. Well, look, we get tx, but look, we get ty quantity squared, plus t squared y. Oops. Yeah, I can't factor out a t, right? Well, I can factor out one t, but look, I don't get f of xy in here, right? I forgot my squared. Yeah, there's this extra factor of t that I can't get rid of inside here. So unfortunately, no, this is not a homogeneous function. All right. So that's it. That's what a homogeneous function is. Now, how does that impact differential equations? That's the next video. And how we solve those differential equations, that's also part of the next video. So as I mentioned last week, this one needed to be in 2 parts, because some of you are probably like, oh yeah, I got that already. That's cool. Hopefully you turned it off at that point. But if you watched all the way to this point, I appreciate it. Hopefully it's pretty clear now. Now the next video is going to be all about, okay, now we know what a homogeneous function is. How does it impact differential equations? So thanks so much for watching this one, guys. And I will catch you on Monday. Oh, yeah, I'll see you on Monday, but because it is only Thursday right now when I'm making this, but I won't see you after this video till, time is weird right now. Bye, guys.